Okay, this is question 15 on the second part of the test of graphing polynomials. Number 15 is from section 5.7. It says write a polynomial function f of least degree that has rational coefficients. It has a leading coefficient of 1. That shows up right there, leading coefficient of 1. And the zeros are 2i and negative 3 plus root 5. Okay? So the first thing is, we know we have x, we have 1 here in front. Well, let me go back here. It's better to talk about this is f of x. And you're going to have a, and you're going to start listing your factors, however many you need. Okay? Well, a is a leading coefficient, so we already know this is going to be a 1, which means it doesn't even really need to be there, because multiplying by 1 doesn't change anything. If we solve this backwards, remember when we solve these backwards, we bring it back here. This is really x minus 2i equals 0. So I'm going to go x minus 2i. Same thing here. X equals this, so when I bring everything backwards, I get x plus 3 minus root 5 equals 0. So I can put that one in there as well. X plus 3 minus root 5. Remember, you want to bring everything over, bring all this stuff to this side of x, to over there. Okay, so that's what I did. Okay, well, the other thing some of you forgot about is that according to the conjugates theorem, this is really, well, first of all, this is really 0 plus 2i, but according to the conjugates theorem, these imaginaries come in pairs, so there's a plus or minus 2i. So really what I have to do is I have to add another one, x, and if I instead of subtract, it was plus 2i and subtract to make it, I'm going to add 2i to both sides. I'm going to have to add it there. So it's going to be an x plus 2i. Okay? And the same thing here for irrational answers. They always come in pairs, so there's a conjugate pair. There's minus 3i and plus root 5 and minus 3 plus root 5 and minus 3 minus root 5. So if I do that work over there, I'm going to get x plus 3 when I add 3 to both sides, and I'm going to subtract, it's minus root 5, so I'm going to add root 5. And we get x plus 3 plus root 5. Okay? So if you were to really multiply that out, I'd rather distribute with these, double distribute with those, and double distribute with those. That would be an answer that would be good enough. The other answer could have been, in red you would have x squared plus 4, and in purple, when you do all that work, you get x squared plus 6x plus 4. If you want to go further, again, you could have stopped right there. You could have stopped right here. If you want to go further, it works out to, when you do all the work, x plus x to the 4th plus 6x to the 3rd plus 8x squared plus 24x plus 16. I didn't require you to go that far. And remember, these things come in pairs. So as soon as I see 2i, I knew it was plus or minus 2i. As soon as I saw a square root, it was 3 minus root 5. I knew it was plus or minus root 5. So that gives me 4 zeros, and I'm in good shape. Whoops. I'm in good shape because I have an x to the 4th if I do all the multiplying out.